Hello, welcome back to Cracking the Cryptic. We've been asked to take a look at this puzzle from dailykillersudoku.com. You can see there it's rated 10 for difficulty, which is their hardest setting, and that means it will be monstrous. If you're new to Killer Sudoku, therefore, you might want to take a look at some of the other videos on the channel first, because this will be really quite brutal, especially as it's been requested, I'm guessing, because it's particularly hard. But without further ado, let's try and see how we might start it. At least you can see this cell and this cell we can write in. I recommend pausing the video, by the way, if I ever sort of make statements like this, just so that you can check you understand why I think we can write in the value of these cells. And the reason is the 45 rule, as it's called. So we know that every 3x3 block like this in a Killer Sudoku will add to the number 45, because it will contain the numbers from 1 to 9. Now if you add the numbers from 1 to 9 you get to 45. We also here we've got 4 cages that are completely contained within this 3x3 block. This 11 cage, the 10 cage, the 8 cage and the 13 cage. If we add these up we get 11, 21, 29, 42. So we know that this cell here has got to be a 3 in order to make the entire block add to 45. And this is a very common and very useful technique in these Killer Sudokus. We can do the same thing down here. Look, 11 plus 13, that's 24, 34, 43. So this is a 2 and this is an 8. Now, what now? Well, this cage here, or this 3x3 block here, has a 23 cage and an 8 cage entirely within it. Add those two numbers, we get 31. Therefore, these two cells here have got to sum up to 14. But you can see that we've got to make 14 without using an 8. And there's only one way of doing that. That means that these two cells are going to have to be 5 and 9. The other way of making 14 being 6 and 8, which is ruled out by the 8 already being in the cage. Similarly, let's just look at this one. 27 plus 4 is 31. So we've got actually these two have to add up to 14 as well, again without using 8. So we have a nice symmetry there. We can put the 5 and the 9 in. And now we need to do more thinking. And normally with these very hard puzzles, we have to, you sort of have to worry away at them and try and find a way in. One thing I'm wondering about here is this sort of odd arrangement of this 22 cage and this 23 cage. Now, ordinarily one wouldn't start here, but with these puzzles sometimes you have to. And we can ask ourselves some questions about the value of this cell. Let's, for instance, if this cell is a 1, what happens? If this cell is a 1, these 3 cells here must add to 22. But 22 plus 22 gives 44, and these two cells, therefore, we'd need them to both equal a half or something in order, because there's only 1 we'd need to make 45. So this cannot be a 1. Ditto, if this is a 2, these 3 cells have to sum to 21. 21 plus 22 is 43. These 2 cells would have to both equal 1. Again, not possible. Let's check 3. Again, not this time not possible for a different reason, because now we have 20 for these 3 cells plus 22, that's 42. So these 2 would have to be 1 and a 2, which contradicts with this one. Now 4, that's probably going to be possible if these are 1 and 3. The interesting thing here is that 5 isn't possible because of this 5-9 pair up here. 8 and 9 also not possible. So the only other things we have to check are 6 and 7. Let's take a quick look at those and see whether we can make any eliminations. In fact, I'm just wondering, the impact of these numbers on this 10 is interesting, but I just spotted this 13 cage over here might be an easier place to look. So we'll come back to this. We've eliminated this to 4, 6, 7. Let's just take a quick look at this 13 cage. Obviously 4, 9 is ruled out because of this 4 here. There's an interesting interaction between this 8 cage and this 13 cage. Because if this 13 cage was 6, 7, we can no longer fill this 8 cage because we can't put 1 7 in, we can't put 2 6 in, and we can't put 3 5 in. So this cannot be 6 7. And as it's not 4 9, it must be 5 and 8. And that actually resolves that number. That must be a 9. Now this 16 cage now, we need these two numbers here to add up to 7 without them being 3 4 or 2 5. So we know these two numbers here are 1 and 6. And we know therefore this number is 2 or 7 and this number is 2 or 7. And all of that is interesting because if we remember where we were with this 4 6 7 cell, we worked out that these two, if this was a 4, these two numbers here had to be a 1 and a 3. Now look at the effect that has on this 10 cage. The 1 3 here would force this to be a 6, obviously, this cell here. And now this 10 cage can't be filled because it can't be 1 9, it can't be 2 8, it can't be 3 7. And this 6 here would force this not to be 4 6 either. So in fact, this cell is not a 4. And now let's just revisit this 34 cage here. And so we need the numbers 2, 3, 7, 8, and 9 to appear in this block because the 5's obviously coming from this cell. Therefore, this 9 cage has to be 4 5. If this is a 6, these three cells add to 17, plus 22, that's 39. So I know these two cells here have to sum to 6. But we can't have 2 and 4 because we already have a 2 in the column. So these would have to be 1 and 5. Now if this is 1 and 5, this again, this would be forced to be a 6. And this 10 cage here would be forced to be 3 and 7. But this breaks down here quite quickly. You can see now we have to place a 1 in this 3 by 3 block. Well, that can only go in this 9 cage. Now this 13 cage can only be filled with a 4 9 combination. Now this 11 cage can only be filled with a 5 6 combination. And now there's no way of filling this 15 cage anymore because you can see that this cell here would have to be a 9 because it can't be a 5 anymore, and that means these two cells have to sum to 6. But the 2 4 option's taken up and the 1 5 option is taken up, so this just does not work. Can eliminate all of that as a possibility. This 1 5 is not right, which means we can take away the 6 there. This has to be a 7. If this is a 7, we know that these two cells here have to now sum to 7 because these three cells will sum to 16, plus 22 is 38. We know we need 45 altogether, so these two have to sum to 7 without using 2 5, and 1 6 is impossible because of this 1 6 cell here. We can't have 3 cells all with just the possibilities 1 and 6. So these two cells have to be 3 and 4, and this is lovely now. Now this 10 cage is forced to be 1 9, which means we can eliminate that there like that, can eliminate this here like that. We need to place a 7 somewhere in the column. This 7 here prevents the 7 from going here, so it must go here, and therefore this must be an 8, which is absolutely lovely. Right, so these two cells have to sum to 8 without using 1 7 because we already have a 7 in the cage, and without using 5 3 because we already have a 3 in the block. So these two cells must be 2 and 6. The 7 here allows us to resolve that way. That must be a 2, that must be a 7 there. 2 2 1. We know there's a 1 over this side of the grid. In fact, we might as well fill in the options for this 22 cage now because it's forced. It's got to be looking at the options 1 5 7 and 9. So It's got to look like that. And now let's look at this 7 and this 7. That means this cell here has to be a 7. And this is really nice again, because look, we've got two 13 cages in row 8 here, and neither of them can contain a 7. So we know, therefore, that they're 4 and 9 and 5 and 8. And in this 3 by 3 block, we already have a 9. So this must be 5 and 8. This must be 4 and 9. I suspect that's going to really limit the possibilities now for this cell here. I think has to be 4 and 7 now. It's the only legitimate way left to make 11 work, and that means we've got 3 and 6 down here. 3 and 6, these two 6s here mean this can't be a 6, so 3 and 6 must go that way round. 3, 8, 9, the open cells here, but this one can't be a 3. 6, 4, 7. This can't be a 9. Resolves those two cells, look. We know these, to complete this 15 cage, we need these two cells to add to 6, but they can't be 2 and 4 because we already have a 2. So this is 1 and 5, which means the open cells in row 7 here must be 3 and 6 in some order. And we can use this 4 to resolve this 4, 7 here. It's going to have to be this way around. 7. This can no longer be a 7. 9. Okay, and we're starting to make reasonable progress. You can note we've got the numbers 3 and 6 here, and in this 3 by 3 block, none of these squares are equal to 3 or 6. Therefore, we're going to have to lock the 3 and the 6 into those two squares there, which means that these 3 squares have to be 2, 7 and 8. Which means that here we've got a 1 and a 4 pair. 1, 1, 4, 3, 6. Okay. So these cells must be 2, 3 and 6. And an interesting point to write is here. We can use uniqueness to resolve this pattern. See, we have a 3 and a 6 here. Now, let's ask ourselves the question, what would happen if these two cells here were 3 and 6? So let's just show you what that looks like. That would make that a 2. Now, if this was the final arrangement, if we got to this point in the puzzle, you can see that there's no way of resolving which way round these 3 and 6 go. This could be a 3, and that would make this a 3, this a 6, and this a 6. Or the other way round. That could be a 3, that would be a 3, that would be a 6, and that would be 6. There's no way using either the arithmetic of the cages, the geometry of the cages, or anything else to resolve which way round is the intended solution. Now, we know that this puzzle will have only one solution. If it's been set properly, it's a good puzzle. Therefore, we know we can't end up with this sort of broken pattern in the final answer. Therefore, this cannot be a 2. We need to break this arrangement. Therefore, we have to put the 2 here in order to avoid that sort of broken pattern. Now, putting the 2 here, is that going to be useful? It probably isn't, but we still have to take advantage of every number we can find when solving these difficult problems. No, can't see how to make use of that further. So how do we make progress from here? Well, this 3, 6 and this 3 mean that there must be a 3 along there, look. And this 11 cage, can't contain a 6, because if it did, the other number would be a 5, and that would break. So the 6 in this 3 by 3 block must be in one of these two positions. Therefore there is a 6 down that side of the grid in this block here. The next thing I'll probably look at is the relationship between this cell here and these two cells. It's a symmetrical sort of arrangement to what we had with this cell and this cell over on the right hand side of the grid. But you can see, let's just take an example, if this cell was a 1, these three cells would have to sum to 20, plus 22 is 42, so these two cells would have to be a 1 and a 2. Now, I can't see a reason at the moment why that's not possible, so 1 would be a valid answer there. But you can see that if this is a 2, for instance, if this is a 2, that means these two cells would have to sum to 4 then, because they're always going to have to sum to 2 more than this cell. Now if these two have to sum to 4, that doesn't work because we already have a 3 in the column. So 2 is not possible. 3 isn't possible for a different reason. If there was a 3 here, this 9 cage couldn't be filled. So imagine this is a 3, that means this is a 4, and these two cells have to sum to 5 without using 1 4, without using 2 3. So that's not possible. This can't be a 3, it can't be a 4, it can't be a 5. So 6 is possible and 8 is possible. And if this was 6, this would not be a 6 then, so we know there would be a 6 in here into one of these two cells, and therefore the other cell would have to be a 2. So let's just keep track of this. So if this was a 1, we knew this was a 1 2 pair. If this was a 6, we knew it was a 2 6 pair. If this is an 8, well, these two cells have to sum to 10. Is there any way of restricting that very much? 1 9, that looks possible, doesn't it? 1 9 is possible. Can't see why 2 8 is not possible. It'd have to be that way round, I guess. 3 7 is not possible, and 4 6 is also possible. So 4 would have to be added to the possibilities there. So this is still quite congested, but we have limited the value somewhat of this cell here. But I guess by the same logic there couldn't be a 3 here. There can't be a 3 there either. So we're left with just this choice for the 3's in this 3 by 3 block. What else can we see? Well, we can see because there can't be a 5 up here, look. The 5 in column 3 is either in this position now or this position. There's only 2 places for a 5, so it's definitely bifurcation possibilities if you're of that mind. What else? Well, I guess this can't be a 1, because if this is a 1, these two cells have to sum to 13. Can't use 6 7, can't use 5 8, and 4 and 9 neither are possible in this cell. So this isn't a 1. I don't think that's going to be terribly useful, but let's think about it a bit more. And then I guess, well, as we've got rid of the 1 here, we can get rid of the 9 here, because that was the 9 1 pair was adding to 10, so that's logical. This 7 here, we can get rid of that 7 there. But these 5 cells here, which sum to 29, so i.e. the 14 cage plus the 7 and the 8, so we know that the 4 cells here must sum up to 16, which is quite a small total. I wonder if it's just worth checking that. So 16 in 4 cells. Okay, you can do that in a variety of ways, but if we eliminate all of the ways that 7 and 8 can occur in, which I've just done there on the screen, you can see we're left with a few options. And now we know that there's only one of 2 positions for this 3 to go in. Let's just imagine the 3 was in this position. Then we would definitely be looking at this 2 3 5 6 combination. That's the only combination that contains a 3 that's still valid for our 16 sum. So this would be a 3, This would have to be a 5. This would have to be a 2 or a 6. That's still either of those is possible. And this would have to be a 2 or a 6. But we know this can't be a 6 because we know that the 6 in this 3x3 block is locked over into this side because of the 3, 6 here. So this would have to be a 2. We said that was going to be a 3, that would have to be a 6, and this would have to be a 5. So this would be a forced combination, if you like. And it doesn't look to me like this works because you can see that this 14 cage now is going to have to be 1, 4 and 9, and therefore this cell can only be a 1. Now if this cell is a 1 and this is a 4 or a 9, this is becoming problematic because you can see that this 5 here, that's going to mean that's a 9. The only way of these cells being filled is with an 8 and a 9, so that cell is going to have to be an 8. So in fact this is going to be a 6, which means we know these two cells have to sum to 8 now. And we can't do that anymore. This cell here is a 4 or a 9, so even if it's a 4, that would be a repeated 4. So all of this means that this combination just does not work. So we can come back to this point of the solve and know that these 4 cells here do not contain a 3. And therefore, this must be the 3 that we were looking for originally. So let's put that in and now see if that gives us any way of making more headway. Well, we can immediately see that allows us to unwind this combination here. These two here have to now sum up to 6. So it's either going to be 5 and a 1 like that, or it's going to be a 2 and a 4 like that. So serious restriction now on these two cells. Just as importantly, you can see that this 3 and this 3 here mean that there is going to now be a 3 in this 14 cage. So the other two numbers are going to have to add up to 11. Therefore 4 is no longer possible here, because if there was a 4 there would be a 7 as well, and that's going to be ruled out by the 7 that's already there. So we can take that 4 out. 5 would have to appear here if this was a 6. 2 could be in either position, and 9 could only be in this position. So this cell is also very restricted now. But in fact, the fact that we've managed to rule out a 4 from either of these positions, and we have this 4 here, means that there is now only one place a 4 can go in this central 3x3 nonette. Can't go in any of these cells, can't go in any of these cells, can't go here, can't go here. It needs to go here, which finally resolves the position of this 2 down here. Now that means we can unwind, oops, if I could type, we could unwind this 1-4 combination at the bottom. So now I've got to be 1 or 6. That's going to be 1, 3 or 6. And now we can, well, we have a 4 here and 4 here, so simple Sudoku rules tells us there's a 4 in one of those two positions. So now this 22 cage, we know we need to make it using a 4, so let's eliminate all of those options that don't contain a 4. There we go, and now we also know it cannot contain a 3, so let's eliminate the ones that have got a 3 in. And we know there's a 6 in one of these 3 positions, so it can't have a 6 in it either, so we can eliminate that one. Now the interesting thing firstly we can note about these two options is that they both contain a 9. So we know now that the 9 is locked into this 22 cage. And that being the case, we can eliminate this 9 here. And therefore that will, no, I'm not sure about the 1 there, I'm going to put that back. And there we go, we've got a 2-6 pair now in row 6. Which ought, I think, to be quite helpful. certainly means this is now the 3. 3, 9, 6. Sorry, just pausing briefly while I study the grid. Maybe let's just try the same thing on this 21 cage just to see what the options are now, because you can see we need a 3 in the cage, so we can eliminate the options that don't have 3 in, like that. And we know there's no 9 in here either, because we know there's a 9 in here and there's no 9 in this one, so anything with a 9 in it we can remove. And we know it can't contain a 4 because we have 2 4s in these two positions, so it can't be that one. So in fact this is 3, 5, 6, 7. And the only square therefore that's going to be is a 6. Which means that, oops, this must be 5 and 7 here. 5, which means this is going to be the 1. And this square here must be an 8. Oops. Like that, which means that's an 8 and that's a 5. I think we're almost there now. We'll just finish it off for the sake of good order, but I'm hopeful that we're definitely closing in on a solution. This square here has got to be a 1. A 5, 9 pair there, look. So they can't, neither of these can be a 9. This is going to have to be the 9. Therefore, we know there's a 4 in here, so it's going to have to be a 4 and a 1, like that. That all looks like it's adding up to the right number. We can remove the 1 here, we can remove the 8 here, the 2, 6 here. Note that there's no uniqueness problem here, just for the sake of good order. We do have this 2, 6, 2, 6 thing, and you might think, oh well, isn't that the same as what we had down here when we had the 3, 6 and the 3, 3, 6 thing that we needed to avoid? But this is subtly different. If you stare at it, you can see that this 2, 6 is not part of the same cage. Therefore, it's perfectly possible for these arithmetic sums here to disambiguate which of these is a 2 and which of these is a 6. And therefore, there is no uniqueness problem with this arrangement. So this, according to the column, this square here can only be 1, 2 or 8, I think. But you can see we've already got a 1 here and a 2 from this combination 2, 6. So this has to be an 8. Which means this is 1 and 2. Can't be a 1 anymore. You can see therefore this has to be a 5 or a 7, but it can't be a 7 because of this. So let's unwind this. It's going to be a 9 now. That's going to be the 7. 3, 6, 8 into those options up the top there. And now we can use the sum here to do exactly as I mentioned before, which is disambiguate the positions of these 2s and these 6s. So it's going to have to be this way round, which means we can resolve this 6, 2 combination. What are the options left for this square? I think only 4 and 7 now work, which would have to be this way round. What are the options now? Well, now this can't be a 6. This is going to have to be 1 and 9, which is going to have to be this way round. Therefore, this is the, oops, this is the 6 and this is the 2. That's a 2. That's a 1. This must be a 9 over here. It's going to be a 6. 6 is 8. 5, 7. Look. very good puzzle as always. These puzzles really are terrific. They are not easy, as I hope you appreciate. I know this has taken me, it's probably taken me about half an hour to finish, and which is unheard of. I mean, there are very, very few puzzles that take that long nowadays. I've been doing these for so long, and it's a testament to the quality of the puzzles on this particular website that, you know, that they are difficult enough that they can take such a lot of thought to actually crack them. They're very good fun, and I have to say I really do enjoy them. I think that they've got a lot going for them. So there we go. Thanks for watching, and we're back again soon with another edition of Cracking the Cryptic.